taking a look at parabolas now. If you graph a quadratic, y is equal to x squared plus 2x plus 16 or something like that, you get a parabola. But instead of starting with the kind of scary looking formulas, we're just going to start with pictures. And we're going to learn to analyze the diagrams first. And then, sorry, I need a ruler. Then we're going to worry about graphing stuff and doing an analysis like that. But we're just going to start with easy stuff. All right, so it's parabola. Okay, the only thing missing on here, and it's just because my software won't do it for me. There should always be arrows on there. If you look at it, you can see it's symmetrical, right? Both sides are the same. And the one thing is, well, I guess there's two things. One, these are curves, they're not straight lines, right? Please don't ever do that. Yeah, it's not, you're not making V's or W's or something like that. But these lines never end up going completely vertical. So always assume they keep going up and up and up and up. Okay, that's kind of all. Okay, it's what I didn't write on here that you should know. Concavity. Does it open up or open down? Well, this one opens up. Basically, if it's a smiley face, it opens up. All right, we need to be able to find the vertex, and the vertex is where it changes direction. So if you think, as with every graph you read, you start reading left, right. So if you hit the graph, you can think of this, it goes downhill, downhill, downhill. It's going down, negative slope. And then it gets to this point, and then it starts going uphill. Okay, that point where you change directions, that's your vertex. And we probably used it in the chapter on triangles, because vertex is kind of another word for corner. But I guess it's not really corner, it's just where it changes directions. But importantly, it's going to have some coordinates. So coordinates are -2 and -1. All right, now, does this have a maximum or a minimum? Well, maximum or minimum, first of all, always refer to y-axis. In other words, you're going up and down. So you start here, it goes down, 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 and then it changes direction, and it goes back up. So this is a minimum. This is as low as it gets. The lowest this gets is -1. So the lowest it gets, that's a minimum. Y is equal to -1. Okay, so value, again, it's always going to be y. It's going to say y equals something, and then you just see how low it goes. If the graph parabola were to go this way, then you'd have a maximum. And I'm pretty sure the one on the next page or in the next video is like that. All right, it says draw in the axis of symmetry. So if I were to fold this page this way, besides it being a mess, the two sides wouldn't match. But if I fold it this way, it would. So symmetry means matching sides. So the axis of symmetry happens to go through your vertex, and it divides it into two nice equal symmetric shapes. So this is my axis. And in the ones we do, it's always going to be a vertical line. Always, 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 always. Always a vertical line, always through the vertex. Okay, the equation of that. Okay, so where you could fold in half again. So remember from, it would have been chapter 6. Right, on linear inequalities, a line like that, it crosses the x-axis, and it crossed at -2. Now, I'm going to show you guys a G, which is really important. When you're doing these, stop when you get here, because then I want you to go back. The axis of symmetry goes through the vertex, so this and that should match. And the maximum or minimum is also at the vertex, so this and this should match. It takes 2 seconds 2, 1, 2, 1, boom, done. You know it's there. Okay, and it's a real easy way to check if you accidentally made a mistake. All right, y-intercepts. Y-intercepts are where it crosses the, sorry, x-intercepts where it crosses the x-axis. One thing you can do when we do graphing analysis, so you can take your highlighter and you can highlight the two axes. Because sometimes there just gets to be so much stuff in there. It's like, what am I looking for? All right, so x-intercepts where it crosses the x-axis. So there's one, there's one. So, and I'm very fussy about this. Intercepts are points -3 and 0 and 1 and 0. So the y-intercept is the same thing. It's where it crosses the y-axis. Now, you need to be careful. What are the coordinates at this point? It's not 3 and 0. It is 0 and 3. Okay, that's another thing I check for. I'll tell you the story another day, but basically I need to make sure that if these have the 0 in the back, when I flip to the other one's got the 0 in the front, basically x-intercept, the opposite one is a 0. Right, so x-intercept y is 0, y-intercept x is 0. That's my brain. Okay, I'm going to write that for you. X-intercept, oops. Y is equal to 0, y-intercept x is equal to 0. Okay, so that's what your brain should say. X-intercept y is 0, y-intercept x is 0. It just automatically flows all together. Sorry, got off on a little tangent there. Domain, what can x be? Well, this thing keeps going. So it's going to keep going wider. So if you, theoretically, you could have an x of 1,000. I don't know how high up that would be on our graph here. It'd probably be a long way, but eventually it would get there. So any number will work. And in math, what do we use to represent kind of, oh, don't think x. Which one of our number systems? Natural, whole, integer, rational, irrational, real, represents any number you can think of. Exactly real. So the domain is equal to the set of all x such that x is an element of real numbers. I'm going to translate that down here. Set of all x such that x is an element of, oopsies, real numbers. And let's just do a quick run through. Okay, whole numbers. Okay, 1 is a whole number. Boom. There's my graph sitting on an x where it's 1. Sorry, that was natural numbers. Whole numbers include 0. Oh, down there. Whoopsies. Where is it? Here's where x is 0. There. The graph is hitting x is 0. I did that first one wrong. I'm sorry. Natural numbers should have been out here. There's x is equal to 1. 1, 8. There's a whole number. Now we have 0, 3. So natural, whole number. What comes next? Integers. No, here. -3 and 0. X is -3. And then our next one out is rational. Well, we could have a fraction. So here. That point is -1 0.5 and 1. Okay, you get the idea. I can put a point anywhere along here and I can get irrational numbers or anything. Anyway, real numbers. Not so much with the y value. If you think about it, the y is coming down and it's getting lower and it's getting lower, it's getting slow, it gets low, 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 low. And then it gets to a point of as low as it goes is -1. And then it starts going back up. So not all numbers. So if I want x is 5, or sorry, y is equal to 5, boom. And it goes and it goes. But if I want y equal to -2, which would be like down here, there's no graph that corresponds to that. So the range is a little bit different. So the range is y such that y now is greater than or equal to -1 y e. So this part remains the same, but y, no matter what you do, it's always going to be bigger than or equal to -1. So if you look at any of these coordinates that I was writing on here, right, every y value you get is always greater than -1. Other than that, real numbers are fine. So basically that just says vertically, I can look at the decimals and it comes out the same. I will tell you a secret though, because this, sounds a little bit scary. Let me do it this way. This part of the range and this part of the range, even got that little comma in there, that is the same every single time. The only thing that's going to change from one range question to another is this part. And if it is a smiley face, that's a great thing. This is how I remember. It's a great thing, so it's a greater than sign. If it's a frowny face, that's kind of sad. So it's the less than sign. And this is always going to be the coordinate of your vertex, the y coordinate. So it looks scary, but there's a pattern to it, so it's pretty cool. Okay. This one reads sort of the same. The range is set of all y such that y is greater than or equal to -1, and y is an element of real numbers also. So the part where it is, we include all numbers. All right, that. I was going to read the hint there, but we already talked about that. So that's it for that video.